All right, so the first thing you're going to set it equal to each other and see where they cross. So just subtract over. Did I write that down right?
That's plus 2.
Oh, so I subtract. So those cancel. Yes?
Yeah.
Negative x squared plus 3x.
Okay, so far so good.
And then where you're going to pull out this. So it's going to be 0 and 3. Good?
That's very good.
Find the area of the region between the graphs 3x cubed minus x squared minus 10x and negative x squared plus 2x. This is when they intersect more than one point. In fact, if you look at the graph they give you, you'll see that you have more than one point, but you won't be given a graph. So the only way you're going to find this out is if you're going to do exactly what we did on bell work. You're going to set these equal to each other. And then solve, of course, for x. So you'll get 3x cubed minus 12x. Factor out. So you are going to get 3 points. You will get x equals 0, x equals 2, and x equals negative 2. Okay. So when this happens, you actually have to set up two problems, right? You want to go from negative 2 to 0 and then 0 to 2. You're going to walk it from the lowest point to the highest point. So you're going to set up this and you're going to set up this. Now, you have to check for every interval as to which one's higher, okay? Because typically for these, it switches. So if I go from negative 2 to 0, plugging in like a negative 1, I will get, if I plug in a negative 1, let's say to this one, we would get negative 3 minus 1 plus 10, right? So we're going to get what? 7, right? 6? 6 or 7, somewhere in there. Positive 6, I think. Negative 1 here, we're going to get a negative 1 minus 2, which is negative 3. So this guy's definitely bigger than that guy, all right? And you're going to end up with this, it's going to be switched. So if I take the 3x cubed minus x squared minus 10x and subtract this, I basically am going to get this guy right here, because that's exactly what I did. I subtracted it over, right? So I subtracted, you get this 3x cubed minus 12x. So this first one's going to be the 3x cubed minus 12x. For this one, from 0 to 2, if I plug in a 1, I'll get like 3 minus 1 minus 10. So I'll get what, negative 8? And then for the other one, I will get negative 1 plus 2, positive 1. So now it's going to be the other way. If you do it the other way, it's always going to be that one just negated. So I'll show you what I mean by that. If I do negative x squared plus 2x and I subtract the 3x cubed minus x squared minus 10x, I get the same, basically the same thing, except it's reversed. I get negative 3x cubed. These still cancel. Negative x squared plus x squared basically is what happens. And then 2x minus a negative 10x is plus 12x, right? So you get the same thing, just reversed. Your signs are different. Does that make sense? And so this one's going to be negative 3x cubed plus 12x. Okay. And then I'm just going to do the antiderivative of those. Just the way I would, for anything. So antiderivative of 3x cubed is going to be 3/4 x to the 4th. 12x is going to be 6x squared. And I'm going to do that from negative 2 to 0. And then I'm going to add to it the same thing, but again, reversed. So negative 3/4 x to the fourth plus 6x squared, and I'm going to do that one from 0 to 2. I get just 0. When 0 is at the top, pay attention to it because it actually changes your sign, okay? When 0 is at the bottom, ignore it because if it zeroes out, unless you have like a constant in there. 0 at the top actually means 0 minus this answer. So that's important because that actually changes it. If I plug in a negative 2, this is going to become 16 times 3/4, which is going to be just 12. Minus when I plug in a negative 2 here, I get, what, 24? So that's what I mean by it changes my sign. 12 minus 24 is negative 12, but I'm subtracting that from 0, so that's positive 12. And then for this one, plugging in just a 2 gives me a negative 12. Plugging in a 2 here plus the 24 here. So that gives me another positive 12. So my final answer here is 24. This is actually, I don't know, I feel like they could teach this with it. Horizontal representative rectangles. Find the area of the region bounded by the graph x equals 3 minus y squared and x equals y plus 1. The only time this matters is if you have 1 in terms of x and 1 in terms of y. Both of these are x equals a function. And so you can literally set it up exactly the same way. You're just doing f of y instead of f of x. So you're just integrating y instead of integrating x. If for some reason they had x equals, like say they had the functions x equals 3 minus y squared and y equals x minus 1. Well, then we have a problem because 1 is in terms of x and 1's in terms of y. And so I would want to rewrite this bottom one here to look like this guy, right? Because they both need to be either x equals something or y equals something. You don't want them to one and one and one to the other. But if they're like this and they're already in terms of the same variable, you simply integrate. You're going to do the regions like this. So you're going to set these equal to each other. 3 minus y squared and y plus 1. And so you get 0 equals y squared plus y minus 2, y plus 2, y minus 1. So you're going to get y is going to equal negative 2 and 1. And so this isn't even multiple, like we only have 2 points. So we're just going from negative 2 to 1. You just need to figure out which one's higher. If I plug in a 0 here, I get 3. If I plug in a 0 here, I get 1. So I know I'm going to have the 3 minus y squared first and the y plus 1 second. And so when I integrate this guy, you can simplify it first, obviously. Negative y squared minus y plus 2, because I subtracted the other way over there. And then just do basic integration. Like this is identical to what we've been doing. Negative 1/3 y cubed minus 1/2 y squared plus 2y. And we're going from negative 2 to 1. Plug it in and solve. Negative 1/3 minus 1/2 plus 2. Here we subtract because remember you are still finding the area. 8/3 minus 2 minus 4. You end up with 9/2. And I can show you the fraction here would be 6s, so. You'll notice the 2 that they have here are the ones they gave us, y plus 1 and 3 minus y squared. So we get these 2, okay? And this is the area that's created. If I were to write it in terms of x, I would get y equals x minus 1, right? And the square root of 3 minus x. It's the same exact region, right? So you literally would end up with the same, the one with y's, your rectangles that you, so remember when we saw for area, we did rectangles and then an infinite number of rectangles and you get the limit theory. So these are, horizontal rectangles versus vertical rectangles. This comes into play. This is actually important when we start doing volume, because when you do volume, you start rotating those rectangles and that's how you get your volume. And so it really does depend on which way you're doing it as to how you're rotating it to get the volume. But this is just a visual representation of whether you're solving for y or whether you're solving for x. But how you solve is the same. All right, so try this one.